Hello team, this is a redux of the base check challenge. The base check challenge I released on May 17th as a prelude or a hint to solving the May 17th challenge, which was all around Mongo ID validation, right? Trying to figure out the date part of that. So with that, I did this because we could absolutely use something like parse int to get that done. And so this is the code that I finished with when I was doing this challenge, the base check challenge, right? Where we converted to a number and then we converted back to a string and checked if that equaled our original number. And it worked pretty good, right? Pretty good. But like all things, if you review something far enough in the future, you're bound to find either bugs or improvements or both, right? It's pretty short, pretty interesting, but I did find a bug that we need to address, right? It's a bug. So right here, if I jump back and forth just to clear out that message, bringing up a comment and looking at something that is binary. Okay, if we look at the binary for 5, that is 101. Okay, well, we don't usually write binary this way. We usually write it as 8-bit, right? So we add another 5 zeros in front of it. That would be an 8-bit binary for 5. And if we send that into parseInt, it will accept that and it will return the number 5. Great. That's working pretty good, right? But then when we convert 5 back to the string with the base, we get 101. We don't get any of those leading zeros, right? And that's a very real problem because now this string is never going to equal the original string. And that's the problem that we are trying to solve in this redo, this update to the video, okay? So with that, I'm going to grab this just so that I can grab my function right here, commenting that away so we still have it and bringing this down. And then we're going to start again. So I'm going to get rid of that, okay? Now inside of here, I want to bring in some code and I did this wrong. There we go. I got it now, okay? So we have our digits and those are going to be all of this, okay? So we have the numbers and the alphabet. It's still lowercase. We're still comparing lowercase to lowercase. We're going to take care of that. But if I do something like a slice, right? And I slice from 0 to base. Well, now we have a really interesting thing where we have created exactly what we need. So if it's base 2, I just get the first two numbers. That's zeros and ones, which is what binary is, right? If I'm base 10, I get all this good stuff, right? So all the numbers, that's how we normally count. Great. If it's base 16, that's hexadecimal. That's everything up to the F. And then all the way out to base 32 is all the numbers and the letters sorting it out, doing the thing, right? So we can totally use this as our test structure, okay? And our test structure is down here. So we go for let character of n dot to lowercase, because again, we want to compare lowercase to lowercase, okay? Could we have done like a regular expression or something like that? Probably, right? But for today, I'm just doing a for loop and I'm doing if, okay? If that character is not in our digits, okay? So digits dot includes character, but I want this to be not, right? So we put the not in there. If character is not in digits, the digits that we sliced out, right? Then we should return false. Otherwise, we return true, right? And again, it works. It works quite well. The small issue now is what happens if n is an empty string or if n is undefined for whatever reason, okay? Well, we can do that really quick. Just up here, we can return early. So if there is no n, then return false, right? Because if we don't do this, what ends up happening is n being empty, it will never enter this loop and it will return true, which is not what we wanted, right? It's an empty string doesn't meet the requirements of a number. So we need to do something. A little bit of extra and getting it done. Now, is it extra code? Absolutely. Are there ways to simplify it by taking this this bit here into something like the every callback, right? The every method. Yeah, we could do that. But for today, mainly what I want to highlight is the fact that we have this problem. And because FreeCodeCamp was nice enough to take the happy path, our original code solved it, but it didn't solve for the future. And the future looks kind of like this, right? So we need to be aware of that and do a little bit more, right? We just need to do a little bit more, making sure that things are where they need to be. Hopefully that makes sense. That's the whole update to this, right? I don't know if you liked it or you hated it. Let me know all that stuff in the comments. Let me know if you actually like these short Redux videos, right? Pulling them forward. Otherwise, for now, this has been Base Check Redux, and I will see you in the next one.